Well, first of all, many thanks to the organizers for inviting me. It's a great pleasure to be here and to be able to share with you some of Facebook's perspectives on how to build AI in an ethical and privacy by design. So I'll be giving you kind of starting with a recap, 3 different perspectives on how we approach ethics at Facebook. I'll start with not directly on AI, but telling you a little bit about the design perspective, what it means from a design perspective to build products with ethics in mind. Then I'll go directly into what matters, which is AI for this conference, and I'll deliver the 2 other perspectives. One will be on an AI product perspective, and I'll tell you a little bit about what AI means today for the company, for Facebook, and I'll spend a bit of time also explaining how we build AI, especially taking into account fairness and bias, how we build it in a fair and unbiased way. The third and last perspective will be on AI research. And here I'll tell you a little bit about how we're advancing the state of art on AI through our Facebook Artificial Intelligence Research Lab, and how we are promoting and supporting also external independent academic research. So design, AI product, AI research. So let's start with, see if this is moving. So let's start with the design perspective. At Facebook, we have an broad ethical responsibility to amplify the good and minimize the bad. But what does this mean when it comes to actually building products? Well, it means 3 things. One, we need to think and consider what we are able to build. And this has to do with what technical constraints, what state of art of the technology we have at hand, what are the available resources that will allow us to build that product. Secondly, we need to consider what we are allowed to build. And here we need to be aligned with our company's policies and practices, but also being consistent with local and national, international policies, laws, and regulations. But third, and equally, if not more important, is what we should or should not be building. And this is where ethics comes into play. So we need to take into account the impact that the things that we're helping to build will have on people, the good and the bad. And this is especially important since we are designing products for millions of people in all parts of the world, and sometimes in ways that we have not anticipated. So let me share with you a very helpful framework that visualizes the main dimensions and components of this equation. And this has actually been put together by our design team. And basically, it provides 4 quadrants that they call the 4 quadrants of design responsibility. And we start with the x-axis. So we have, from left to right, we have pixels all the way to ecosystem. And this is about the scale of the things that we are building and in increasing size and volume. We start with small pixels, we go to the broader product, and we go all the way into the ecosystem in which that product will be operating, will be interacting. And here it's important to take into account how that product will actually be interacting with the ecosystem that will be surrounding it. And this gets complicated because the more you move from left to right, the more interdependencies, constraints, and complexities you will meet and you will face. So take, for example, a simple product like a cleaning product. And it does particularly well the task of scrubbing your kitchen counter. It does that really well. But what happens if that cleaning product actually is released into the water system? You might have unintended effects there, systemic effects, because it might actually cause damages. It might harm plant and animal life. So this is when it gets to understanding how the product interacts with the environment, what systemic and network effects might be triggered. Now let's move to the other axis, the y-axis. And here, what we have, whoops, sorry, moved too fast. Here we have it's the same idea, but the scale here that we're talking about are the audience that you're designing for. So we start at the bottom with one individual human. Then we go up and we're actually designing for our user product base. And then we go and we go all the way until you're actually designing for the whole society and even humanity. And here, what is interesting is that the more you move from the individual to the humanity, the less you will assume and you will know about the audience that you're designing for. You will know less about their motivations, about their needs, about how that product is actually impacting, how the product is actually impacting that audience. So we have, Facebook has been used for in many different ways. So you can have people that have actually organized social change movements like the Women's March. But we also have people that have used and misused Facebook to interfere with elections or to spread hoaxes. So here we need to take into account how that ladder from the individual and humanity will play. And the more you will go up, the less you will know, and the more you need, again, to take into account unintended effects and misuses. So here at the left bottom quadrant, this is where designers feel particularly comfortable. This is where they can really craft their art, where they can push their pixels and create something that they feel very comfortable with, because they know exactly what is the audience that they are intentionally designing for, and they know what tasks that product will do and how important will be for the users. But then when we move up, then we move into the space of unintended, unanticipated consequences. And we only know about these unanticipated consequences when they reveal themselves at scale, when you have a lot of people using it. And the same thing applies to the top quadrants. And here, what is interesting to understand is that when you're designing for the world, for society, you're going to encounter different challenges. Because Facebook does not work in the same way everywhere in the world, and people in different parts of the world use Facebook in different ways. So we need to take into account also that complexity of how the social context, the political context, the social norms, the economic conditions of the users, plus public policy laws, plus economics, plus sustainability design will all work in that top quadrant and will influence how that product will be used and will resonate with our community. So these top quadrants are the place of unintended effects of how our products are being used. It's a space where perhaps social bad actors or societal forces will collide with the good intentions of our designers. So what we need to do is actually to design for the 4 quadrants. So this is the space where the ethical responsibility design lies. This is where we take into account the need to think expansively about the impact that our technology, that our innovation is causing on our community, how it's resonating there. And this is where you need to think not only about what you're able and allowed to build, but what you actually should be building. So that was the first perspective. Let's move quickly to the second, and here we're talking about AI. And AI, as you can imagine, is increasingly important to the company. In fact, Facebook without AI could not even exist. AI is foundational to everything we do. It's behind improving existing products, and it's about creating novel experiences to our users across our platforms. And most importantly, AI is also deeply connected to our mission and to our values. So bringing people the power to build community and bringing the world closer together is all what AI is actually helping us to do. So let me give you an example. AI being at the core of our engineering efforts is actually behind some of our most used features. One example is the newsfeed. So the ranking of the newsfeed of the content that you see is powered by machine learning. So we take into account signals like how many people react, how many people share, how many people comment posts that determine how high up that post will end up in your newsfeed. Now let's talk about how AI can help bring people together. And here I have an example of natural language processing, of how we use that technology to help people communicate, even if they don't share the same language. And how we do that is that we use that technology to actually process automatic translated posts. So you have people that do not speak the same language that I can actually not worry about how it's being translated because AI can do that for them. And nowadays we're doing overly 6 billion translated posts a day. Then there's another example. So when we talk about bringing people together, bringing the world closer together, this is all about defying distance. And there are a couple of ways to do that. There's what I would say like the traditional way, which is about enabling people to communicate and to share content instantaneously. I would grab my phone, I would take a selfie, I would send it to my mom, and I'm sharing an experience. I'm with her doing that. That's the traditional way, about sharing content. But then there's another way. There's a way about actually enabling people to meet and be in the same shared space, even if they, in reality, are physically distant. So what we have here is the future of AR and VR which AI is underlining, that will allow us to connect with anyone, anywhere. So just imagine that you'll be able to live anywhere in the world, eliminating commuting. You can be at the birthday party, being truly present there, even though you are all the way across the globe. Just imagine that. So for this, to build this, we need a deeper sense of connection and co-presence. We need to make people to make them feel that they're physically present in the same space through someone else, and being able to communicate their expressions and their ideas without effortlessly. So, and this has to do with facial expressions, with voice tone, with gestures. So what we need basically is lifelike avatars. So developing realistic avatars is the next stage of augmented reality and virtual reality that will allow us to have those technologies being part of our daily lives. And we have a project called Codec Avatars that actually allow, by building ultra-realistic avatars, to have two people sharing the same space and interacting in real time in virtual reality. So let me give you an example. I don't know if the sound is working, but let's watch this playback of Nadia conversing to Dan through their ultra-realistic avatars.
What do you do for exercise?
I do yoga and then I do boxing too.
So what we have here, this was very short. So what we have is that the sensors in Nadia's prototype headset are measuring her facial expressions and are translating them in real time to Dan, who can see a perfect picture representation of Nadia's face, facial expression, voice, tone of voice. And this is done in real time. And it's about really translating not only who you are, but really conveying what you look like, what you sound like. But obviously, and the important part is that AI is underlining this process. So the Codec Avatars project is a result of a process that uses machine learning to collect, learn, and recreate social human expression. It's about training neural networks to map movements and expressions to voices. And obviously, we are achieving very good results in terms of realism, of capturing the faces, but we all know that in order to capture genuine human communication, you need to not only look at the faces, but the rest of the body. So you need to require full body language. So let me give you an example of how we're doing this. And obviously, this is all very early stages. We are still years away from this, but this is where we're moving. And this is what AI is allowing us to do as bringing people together. So this is an early prototype of a simple live interaction. So what we have here is that two people that could be very distant, that could be remote. One could be here in Germany, the other could be in Sydney. And they're actually animating their avatars in a shared virtual space, which in this case is the soccer field. So what we're doing, I don't know if this is playing. It didn't play. Let's try again. So I want to show you this simple live interaction of how immersed people are. Yeah, I go back, but So you can see they're warming up, and they're actually going to play a soccer game. And you can see how immersed they are, how they play with the ball going back and forth like it was actually there, and like they were actually in that shared virtual space while they could be really distant. So this is about really getting people immersed through that representation of avatars. So the point here was really to understand how AI can allow this. Obviously, we're still years away, but we're thinking about important ethical questions about this. And one is how to make sure that body models will work equally well to different body shapes, sizes, skin tones. So we will need diverse data training sets to make this happen. We also need to take into account that there might be important privacy and security questions. So we need to understand, like, is that avatar authentic? Is it you? Is it unique to you? How can we prevent people from accessing your avatar? So technologies like face recognition and fingerprint can actually make sure that the device you use to animate your avatar, you only have access to it. The other thing about AI that is important, and we're still in the AI product perspective, is how important AI role in keeping our community safe. So here, through AI, we are becoming more and more effective at removing bad content from our platform and keeping non-violating platform in. So, and we've been reporting publicly these efforts across different categories of content. And what is important here to note is that through AI, we're actually able to find and flag content that we will then be actioning on before users report it. To give you an example, on fake accounts, we're actually able to find 99.6% of fake accounts before users actually report it. So only 0.4% of accounts that we act on because users report it. All the rest is actually being done through AI. And this brings me to our AI ethics approach. And here we are investing in three main pillars: in the people that are building the algorithms, in the data that we use to train the algorithms, and in the algorithms themselves, because they ultimately represent what AI learns. In terms of people, we are investing in people that build the technology, in people that review the technology. So I'm part of the review team back in the headquarters, where I review artificial intelligence and machine learning features. So we also invest on the people that are doing that review. And then finally, we also invest in people that are represented in the data sets. AI is a product of the data that is trained on. That data comes from our community, from people. So people do play a role at teaching AI. And we need to understand who these people are, because if AI only learns from a small set of people, it will only have a narrow point of view. So diversity here is fundamental. The other important point is data. We have important processes in place to make sure that the data that is selected and annotated is done in a privacy-friendly way. And then ultimately, we have the algorithms. And here is that even if you annotate the data, even if you select it flawlessly, perfectly, algorithm might still learn or propagate biases that were present in the data training set. So here, let me talk a little bit about fairness. And fairness is something that you cannot solve merely through an exclusive technical standpoint. It's not about having a group of engineers that will come up with a fairness library, will upload algorithmic bias module, and through that will just extract all biases from their data and from their models. It's much more complicated than that, because fairness is actually a process. And it's about following a best practice in three of them: surfacing hard questions about fairness. We need to understand who are the people that are being impacted by automated decisions and how we subgroup them. We also need to understand what perspective of fairness we should follow. Is it about ensuring consistency, procedural consistency to everyone, or is it about striving equal outcomes across different groups? Are we talking about fairness in terms of treatment or in terms of outcomes? And then secondly, we need to resolve those questions and come up with decisions, understanding for a given product, taking into account its goal, what is the best definition of fairness. And third, we need to document. We need to record those decisions for the sake of transparency and accountability, and build case studies that will ensure consistency. So we don't need to reinvent the wheel, and next time we have another challenging product, we can go back and understand how we've dealt with that product. And here, we need to do this at every step of the implementation process. It's about how we're defining ground truth, about how we generate labels that train the machines, how those machines are making predictions, and what decisions and interventions we make based on those predictions. And in every single step, you have potentially different biases that might emerge. They might emerge from the labeling practices of our human annotators having their own prejudice or biases. And that's why it's so important for us in the data annotation phase to have a team that ensures consistency of labeling practices. They actually draft guidelines that are approved and that make sure that the human annotators will minimize their bias that go into this exercise. We can have bias in the algorithm, as I've explained before. You can have over-predictions or under-predictions. So we need to calibrate the scores there. And we do a lot of subgroup calibration, in fact. And then we have intervention bias. And this is about deciding the decision threshold of when to intervene. When do we, for example, building a machine learning classifier to detect false news, we will get a score from 0 to 1. When is the decision threshold? Is it 0.7, 0.8? And what does that mean for the different groups that are uploading information to Facebook? So you need a decision threshold that will be applicable to all groups in the same standard way. So we hold content equally through the same standard, irrespectively from where it comes from. And in this process is super important, obviously, to leverage the external community, because they will have the questions that we don't. So, in order to run out of time, the third perspective is the AI research. And here I'll just talk a little bit about the Facebook Intelligence Research Lab, and which mission is really to advance the state of art of AI through open research. They are 5 years old. They have over 160 people spread in different locations, 7 of them. But what does it mean actually to do open research? It means a couple of things. It means, first of all, to publish their results in peer-reviewed journals and conferences and making it publicly accessible to everyone. It means contributing to the open source community by publishing data, code, and models. And it means also to enter into research agreements with reputable academic institutions. But what is next for AI? And here I'll just give you what are we interested in and what problems we want to solve. And I'll just leave you with 2 examples. One is actually to try to make a machine smarter, but not in the narrow sense of just having a machine being really good at doing a specialized task. This is actually, we want machines to understand the world where we live in. We want to make machines understand the world that surrounds them. So if you take into account a baby that just comes to this world, he will not have a good idea of the physics. Now, if I drop this clicker, it will fall down vertically. It will not simply go up or go horizontal. Or if I let it fall, it might stay still the same solid, or it might break into different pieces. This seems very intuitive for us and makes a lot of sense, but machines do not know that. So actually, we have a project in place to make machines understand the physics of the world. So here what we have is this cube's understanding where they would fall. The one at the bottom, the machine, actually is a very naive model, does not know where the cube will fall, so it thinks it will be a bit everywhere, while the other is actually getting it right, getting the location where it fall. And understanding the location of that cube will also allow us to predict the future more accordingly. Then the other one is the creativity. So we're actually training machines to generate photos of clothing. And as the model learns, it actually stabilizes and generates more and more creative pieces of clothing. And you can see this in the future being used by artists to actually leverage this technology to create new pieces of art in new domains like painting, fashion, composing music, or creating animation videos. Last, I will finish with, sorry. I'm going back. Apologies for that. So the last slide, I promise I'm done. So apart from all the in-house research that we do, we're also very invested in promoting and supporting independent academic research. This is what we've done recently when we announced supporting the creation at the Technical University of Munich of an Institute for Ethics on AI. And why we do this because mainly we believe that we do not have all the answers, and neither we should have them. And because some of the questions go way beyond Facebook, and they go beyond even AI as a technical discipline. And academia is best equipped through interdisciplinary research to seek those answers. So with that, and I thank you for your attention, and I apologize for going a little bit over time.